Hi everyone, this is an example of how to write a net ionic equation. Here's the situation. Chlorine gas reacts with aqueous sodium bromide to produce liquid bromine and aqueous sodium chloride. We're going to follow 3 steps. We're going to write our traditional equation with states and balance it. We're going to dissociate anything that's aqueous. And we're going to cancel off anything that's identical on opposite sides of the equation and rewrite what's left behind. We have chlorine gas reacting with aqueous sodium bromide. Chlorine gas, Cl2 gas, reacting with aqueous sodium bromide. To produce liquid bromine and aqueous sodium chloride. We have the chemicals, I have the states. We need to balance this equation. So we have a balanced equation with the states. There aren't any ions in it. This is a non-ionic equation. Anything that's aqueous, we're going to separate into its ions. Solids, liquids, and gases do not dissociate. We're going to end up just recopying them. Here I have Cl2, gas. Gases do not dissociate. I'm going to recopy it down. Now I have 2 sodium bromides and they're aqueous. It is aqueous, it's going to separate into ions, it is going to dissociate. I'm going to get sodium ions and bromide ions. It's 2 NaBr. The question I'm asking myself is, how many sodium ions am I going to get? Oh, there's 2 sodiums. The notation here is quite specific. I need to have 2 sodium. The positive charge must get shown, and again, it's aqueous. I'm also going to get bromide ions. I'm asking myself how many bromide ions will be produced here. Well, there's 2 of them. That takes care of the reactants. On the product side, I have Br2 liquid, bromine liquid. Liquids do not dissociate. I'm going to recopy that chemical down into my next line. Br2 liquid. I have 2 aqueous sodium chlorides. Because it's aqueous, it is going to dissociate. Just like I did with the sodium bromide before, I'm going to separate this into its ions and also show the appropriate number. This is 2 sodiums, but it's also 2 chlorides. This second line, which is full of ions, it's the total ionic equation. This line can get quite long as we dissociate any aqueous substances. My next step is to examine this equation, see if there's anything that's identical on either side. Cl2 gas is not the same as 2Cl minus aqueous. That's not identical. We're not canceling that out. 2Na plus aqueous, 2Na plus aqueous. That's exactly the same. That is going to cancel out. Our sodium ions here are spectator ions. They did not change during the course of the reaction. I have 2Br minus aqueous and Br2 liquid. That's not the same. So I've canceled off the only thing that I could, and my final step is to rewrite what's left behind. I've arrived at what I think is the net ionic equation. To double check my work, I can review the entire process. I wrote the initial reaction, a non-ionic equation, traditional balanced equation. I was careful though to include the states. Anything that was a gas or a liquid or a solid for that matter, I end up recopying. Anything that's aqueous, I separate into ions. The aqueous compounds undergo dissociation. I do have to be slightly careful to make sure that I have the correct coefficients for those ions. Then I examine my work very closely to cancel out any spectator ions. Any substance that is identical on either side of the equation gets canceled out, and I rewrite. If I've done my work correctly, this final line should be balanced in two different ways. The chemicals themselves are balanced, Cl2, 2Cl, 2Br, Br2. However, in addition, the charge of the left and the right-hand sides are also balanced. The Cl2 here is neutral. Here I have two negative charges. So the reactant side of the equation here has a 2 negative charge. On the product side of my net ionic equation, the bromine is neutral, but I have 2 negative charges. My net ionic equation has the chemicals work out to be balanced. However, in addition, the charge is also balanced. And I hope that helps.